So like I said earlier, slash what you've probably gathered from the blue kit we just did, this unit is all going to be relying on your ability to find slope of lines, so that then we can use these slopes for other things in geometry. Now, slopes is an idea from our algebra classes, so I would know we've all taken algebra before with varying levels of success. So we're going to pretend like today, I'm pretending like you've never heard of this before and I'm teaching you from scratch. If you already know these things, that's great. It's just a refresh for your brain. If you never quite got it in your algebra class, today's the day to get it. I want you right now with your highlighter to highlight this word, our first vocabulary word, slope. That is going to be the focus of today. Now we're applying slope to many things, but we're going to have to first find slope. There are many different ways to find slope. So slope is defined to be the steepness of a line. Okay, so when we're talking about a slope, we're talking about how steep the line is. That's going to be our slope. It's represented by the coefficient of x in a linear equation. And if you remember, the coefficient of x in a linear equation is the letter m. So we use the letter m to talk about slope all the time. Now, there are many different ways you can find slope. In Algebra 1, you probably put your coordinate points in a table on Desmos and used a regression to figure out what m is equal to. Great, fine. We're not doing that this year. We're going to actually use the slope of a line formula. So right now with your pencil, I want you to put a big little cloud bubble around the equation part of this definition. It says y2 minus y1 over x2 minus x1. That's going to help us find our m, or our slope. So just like when we used a formula for like distance formula, you're going to have to make sure you're labeling your coordinate points so that we put them in the right spot. We did not mess up on distance formula when we labeled our points, so we're not going to mess up on slope formula when we label our points. But there are 4 kinds of slopes you can get when you do a slope of a line formula. With your arms right now, what does it look like for a slope to be positive? Yeah. Those of you who actually moved your arms, thank you. A positive slope looks like that slope is going uphill. If you were walking along the line that we just drew on my coordinate grid, you'd be walking uphill. No matter what kind of uphill, super steep uphill or only slightly uphill, that's a positive slope. With your arms right now, what does a negative slope look like? Yeah, downhill. So any sort of downhill is a negative slope. If you were walking along that line and you were like, whoa, I'm walking downhill, that's a negative slope. The other 2 are very specific cases. For a slope to have, or for a line to have a slope that is 0, what does it look like? Yeah, it's just flat. A flat line has no slope because it's not inclined. It's not going uphill, it's not going downhill, it's just flat. So that's a 0 slope. Undefined, however, is like kind of the other direction that we haven't talked about yet. What does undefined look like? Yeah, straight up and down. Very good. So any of our straight up and down vertical lines are going to have undefined slopes. If you also remember back to Algebra 1, you probably used this acronym to talk about 0 and undefined. You may have talked about HOI and VUX. Do those words sound familiar to you? HOI stands for horizontal lines, flat lines, have 0 slope and their equations are y equals. They touch the y-axis. VUX lines, they're vertical, they have an undefined slope, and they touch the x-axis. Their equations start with x equals. Okay, so really, again, today we're going to be focusing on just the slopes part of parallel and perpendicular lines. And again, because I don't know where we're at with finding slope, we're going to use that clouded formula every single time to find slope. So in problem number 1, it says determine the slope. Cool, great, awesome. We start with labeling. I'm going to label underneath 3x1 and underneath 4y1 because that's the first set of x's and y's. And underneath 3 and negative 4, that's going to be x2 and y2. Do we follow? Just like we labeled for distance formula at the beginning of this class. Now, our slope is going to be found whenever we follow that clouded formula on the top of our paper. What letter goes first in the very top of that formula? Y2. So what number am I going to put down first? Negative 4. And then I'm going to subtract what number? Look at your formula. What's the next letters? Yeah, y1 is next, and we labeled y1 as 4. So x2 is going to be 3, and then we're going to subtract x1, which is 3. Okay, cool. This is where it comes to your calculator. I don't want you to do this in 2 parts, which is why I don't want you to use your phone calculator. I want you to use your Riello calculator. Use the fancy fraction. Last unit, when we did probability, I told you not to use the fancy fraction because we wanted decimal answers. I want fraction answers this time, so we use the fancy fraction. How do we get that fancy fraction to show up on our screen?
I think it's alpha.
Alpha.
Y equals.
Alpha y equals. Okay, go ahead. Your turn. Alpha y equals. I want you to type this in just as you see it. You do -4 minus 4. Go down to the bottom. 3 minus 3. I'm so glad you said that. When you type this in, you should have gotten an error. Look what's happening in the bottom. What's 3 minus 3? Can you divide by 0? No, this is why our answer for those vertical lines is the word undefined. So the slope here is undefined. What I wanted you to learn from this is, number one, if you type this in the calculator and the calculator tells you an error, number one, make sure you typed it in right. But number two, that's probably an undefined slope. So that's okay. That's actually a good answer. It's just the answer undefined. Let's do the second one together. Now, again, I want us to focus on using that formula, and I know in Algebra 1 you might have learned rise over run. That's great. That's a backup plan for you. But for me, I need you to use the formula. So we're going to label our points. This is going to be x1 and y1. This is going to be x2 and y2. Why? Just because I decided. You could have picked the first ones to be number 2s and the second ones to be number 1s. This is just how we're going to label. Because now that we have it labeled like this, we know exactly what to fill in our formula. Jordan, what's the first number I'm going to use in my formula? 4. Fabulous. Okay. After 4, we need to put in y1. What have we labeled as y1, everybody? -4. So I'm going to do that. I'm going to do the double negative thing. I'm choosing to do that right now while I'm learning. In the bottom, what's the first number I use? 3, and I'm going to subtract what number? -1. I know that's minus and negative. As long as you know the difference between minus and negative in your calculator, that's fine. Okay, calculator time. Use that fancy fraction. Alpha y equals enter. I want you to type that exactly in. When you throw that in your calculator, what do you get? It should be -2. No? Is it -2? No, you're right. It's 2. Ah, psych. I can do math. Happy Monday, everybody. Okay, cool. Do we feel like we get it? Yes? Number 3 is for you. I want you to go from start to finish. Start by labeling your points. Fill in your formula. Go to your calculator. You should also get a number answer for this one. So here's how I worked this one. You may have labeled your points differently. Don't stop just yet and erase anything, because if we did it right, we'll end up with the same numbers. So I labeled the first ones up at the top, x1, y1. The second one's x2, y2. When I plug it in my formula, it should be y2 minus y1 over x2 minus x1. If you type all that into your calculator is going to give you a nice, cute little -1. Did we do that part right? Guess I should follow my own color code pattern and use red down here. Okay, now for the last one, I've still given you coordinate points, but I gave it to you as a table. So when we label these, we just need to make sure we're labeling correctly. The process has not changed. This first column is going to be x1 and y1. Those are the first x's and y's that I'm given. I'm going to label the second one x2 and y2. So they still gave me coordinates, but they gave it to me in a table. Not a big deal. I'm going to still do the exact same thing. Okay, so we pick up our pencil, we write down our formula. What have we labeled as y2? -2, and then we're going to subtract y1, which is also -2. In the bottom, do I put 1 or 2 first? 2, because that's what we labeled as x2. And then we're going to subtract 1. Go ahead, go to your calculator, type that in with the fancy fraction and everything. Alpha y equals enter -2 minus -2 divided by 2 minus 1. What does your calculator tell you when you do that? 0. 0 is correct. Our slope is 0, so that should be a flat line. So it's really easy to double check on these to make sure you have the right direction. I mean, I earlier messed up on number 2 and tried to say it was negative, and very obviously that's a positive number, so I should have a positive slope. Okay, check. Does all of this sound familiar from Algebra 1? I would hope so, especially because some of you had me from Algebra 1, so I know we did this. Okay, but what we're going to do to apply this to a little bit more is combine some more ideas from Algebra 1, specifically parallel and perpendicular lines. Parallel lines, if we think back to what Algebra 1 is, these are going to look the same. Meaning, parallel lines are lines that go the same direction. Did y'all remember that on the blue kit this morning? Parallel lines go the same direction. Now in geometry, we like to use nice geometrical notation. I'm not going to write down the words parallel pretty much ever again. I'm going to use the symbol for parallel, which is 2 parallel lines sticking straight up. The way that you remember this is that the name parallel literally has the symbol in it. Do you see those pair of L's right there? That's the same symbol that we're going to use for parallel lines pretty much from here on out. So definition-wise, it says lines are parallel to each other when they do not cross and their slopes are the same. That's all stuff we pretty much remember from Algebra 1. Parallel lines do not cross, they go the same direction, so their slopes are the same. So what we do to check if lines are parallel is we just look at their slopes. Looking at y equals mx plus b for a first equation and a second equation, do you see that the number in front of x is the same? Those are parallel lines. So we'd say these are parallel. That symbol means parallel. But if we look at the b equations, I could tell you right away that the slope of the top one is 1/2. Can you tell me right away what the slope of the bottom one is? Is that in the format where we can just point at a number and be like, ah, that's slope? No, it's in standard form. We can't tell anything about slope in standard form, so we're going to have to remember how to solve for y. Ooh, it's 2 steps and we can do it. The first thing we're going to do to solve for y is move the x term to the other side. If I pick it up and move it to the other side of the equal sign, what happens to the sign of 3x? It becomes negative. It changes to the opposite. So it's going to say this. Now it's going to say negative 6y equal to negative 3x plus 18. Is everyone okay with that? I've taken something from the left side of the equation, moved it to the right side, so its sign changed. Cross the line, change the sign. Now, Chris, to get that y by itself, what do I have to do with negative 6?
You convert it, make the line down.
Oh, you're talking about like this?
Yeah.
Okay, but how do I specifically get rid of negative 6?
You do plus 6 on each side.
So close. Right now, I see why you said it because this is negative. But right now, these are multiplied together. And I have to get rid of the multiplication. So what do I do to get rid of multiplication? I divide. So I'm going to divide every single thing in this equation by negative 6 so that negative 6 goes away, which means I have 3 different times that I'm doing divide by negative 6. The first negative 6 is divided by negative 6, so they cancel out. That's just y. In your calculators right now, what is negative 3 divided by negative 6? Make it a cute little fraction for me, please. What is that? 0.5, which is 1/2, yeah? And then 18 divided by negative 6 is negative 3. Not that that's really important for us because we wanted this number. What do you now notice about my first equation and the second equation? What do you notice about their numbers in front of x? They're the same, which means these two lines are parallel. That's what we have to have for lines to be parallel. Their slopes have to be the same. We can't trust our eye judgment anymore on graphs. We're going to actually trust the slopes. So we're going to be finding slopes today to verify that lines are parallel. Sound good? Okay. Another way lines can be related to each other is called perpendicular. Now again, you probably recognize these from the blue kit we did at the beginning of class. The perpendicular lines are the lines that meet at what kind of angle? They meet specifically at a right angle. Just like with parallel, I'm not really going to write the word perpendicular anymore today. I'm going to use the symbol for perpendicular, which looks like this. It's not written in the equation like with parallel, but what do you notice? What does this look like? Sort of. I guess I should write it where it actually touches. It kind of looks like a right angle, yeah? That is the mathematical symbol for perpendicular. Perpendicular has a lot of letters in it. And you know, mathematicians are lazy, so we're going to use the shortcut, and we're going to use that symbol for perpendicular. Lines are perpendicular to each other when they cross at that right angle, and the slopes are called opposite reciprocals. This one is huge. Opposite reciprocals. Opposite reciprocals means that the products of their slopes is -1. That's cool, that's fine, that's dandy, but the handy-dandy version of it is the fact that they are opposite signs, flipped fractions. So we're going to write that down. We're going to say opposite sign, flip fraction. Okay, so if we want to make opposite reciprocal numbers, we just want to take whatever fraction or number we're given, use the opposite sign, positive or negative, and flip the number over. So if I tell you 1/2, what is the opposite reciprocal of it? It would be negative, yes, well, it'd be -2/1. See how I flipped that fraction and changed the sign? But yes, I don't have to write the over 1. That's the same as just saying -2. I don't really care about this part, so we're going to cross that out. If you care that they multiply to make -1, if you multiplied -2 times, -2 times 1/2, you'd get -1. That's why they're opposite reciprocals. We don't care. We care that we flip and flip. Okay? So if I tell you one of your slopes is -4, well, it's negative, so the one I want to give is going to be a positive number. But how do I flip the number 4? There's nothing to flip it with, right? Or is there? What sneaky number is underneath that 4 right now? 1. So when I flip it, what number is this going to be? Over 4. That's my opposite reciprocal number, so that's my opposite reciprocal slope. You change the sign, you flip the fraction. And again, I don't really care about this. They would multiply to -1. And prove it to yourself if you care, but we flip and we flip. Is that cool? All right, fabulous. To the back. This is the meat and potatoes of today. We need to be able to not just identify slopes and be like, cool, I can throw things in a calculator, but actually decide if lines are parallel or perpendicular to each other. And not from a graph, like we did on the Blue-Kit, but from actually finding their slopes. So, if we are trying to decide if things are parallel, perpendicular, or neither, you're going to use this flow chart. Step 1, you need to find the slope of each of the lines. After that, the first question you ask yourself, are the signs the same? Meaning, are they both positive or both negative? If you say yes, they're the same sign, you ask yourself, okay, well, is it the same number? If you answer yes, then those lines are parallel. If you answer no, then those lines are neither parallel nor perpendicular. Back here, when you asked yourself about the signs, if you said no, you think about the particular fractions you have. Are they flips and flips of each other? If you say yes, it's perpendicular. If you say no, again, it's neither. So we have a very specific flow chart for ourselves to decide the answers to these questions. Let me show you one, or part of one, and you're going to help me finish it. So in number 7, we have these 2 lines. We have line 1 and line 2. We need to first find the slopes of both of these lines. So, okay, the way Miss Quigley taught me to do slopes is to label my points and then use that slope formula to figure out what the slope is. Now, again, this slope formula is on the front of your paper, and I know when you're looking at examples, you hate flipping back and forth, so I want to show the work here. I'm going to actually put the equation down right now, and I recommend you doing the same thing so that you don't have to look further than the back of your paper for this equation. Okay, that's just so you don't have to flip your paper back and forth. But when we actually do this with the numbers I wrote down for this problem, I wrote down that y2 is 2 and y1 is 0. I wrote down that x2 is -2 and x1 is 2. When I go to my calculator and I type that in, I literally press alpha y equal enter, 2 minus 0 over -2 minus 2. My calculator spits out to me that the first slope, the slope of line 1, is -1/2. So we said this was line 1, so we say M1, talking about the first slope. I need you to help me out and finish the second part. You have line 2 for this problem. Do the same thing. Label the points, throw them into this clouded formula. You don't have to write the formula down again. We've already done it once on this side of the paper, but plug the actual numbers in and tell me what the slope is. I'll give you a few minutes to do that. So we start off with labeling. Plug the points in to the equation. 4 minus -2 over 4 minus 1. We turn to our calculator. We would get what? What is our slope here? Nobody's ready to answer this? 2. Okay, our job now is to compare these slopes together. So following my flow chart, we did step 1 where we found the slopes of both of these lines. The first question is, are the signs the same? No, so we follow this side of this flow chart. Are they opposite reciprocals? Are they flips and flips of each other? So if I wrote 2 as a fraction, it would be 2 divided by 1, right? Are these two numbers flips of each other? Yes. And they're opposite signs because one's positive, one's negative. Which means that we would answer that these two lines are perpendicular because the slopes are opposite reciprocals. So we give both the answer, perpendicular, and the reason that their slopes are opposite reciprocals. Now you're going to see questions like this one a lot today. So if you wanted to put a star next to something, be like, this is the one I'm going to see a lot. Number 7 is going to be very helpful for you. So we found the slopes of both lines, then we compared the slopes to each other. We're going to do the same thing in question number 8. I'm giving you 2 different lines. However, in number 8, I didn't give you coordinate points. I gave you equations. Don't think too hard about this one. What's the slope of line 1? 2 over 3. We know this because this is the m. We know that mx plus b is how we write equations. So we know that that is the slope. Can you look at equation 2 right now and tell me what the slope is? No, it's not in the correct form. Now we solved for y earlier and I led you through it. I know it's on the other side of your paper. But if you flip over to that example, what's the first thing I did? I moved something. What am I moving? I'm going to move that negative 3x over. Okay, if I take that 3x and move it over, what does it become on the other side? Positive, very good. Cross the line, change the sign. So this is going to be 2y equal to positive 3x plus 12. Now Chris answered this earlier, so it's going to be somebody else's turn this time. So Maya, what do I do with this number 2 in the very front to get it to go away? Very good. I divide it away, and I divide every single thing by 2. Pow, pow, pow. All divided by 2. The 2's here are going to cancel, so we have y equal to 3 divided by 2. Is 3 divisible by 2? No. So we're just going to leave it as the fraction 3 over 2. Is 12 divisible by 2? Yeah, it becomes 6. Oh, look at that math we just did in our head. Okay, question. Now that I've written it like this, what is the m? What is the slope? 3 over 2. All right, fabulous, because we know that's my m. Now that we know the slope of both lines, we just compare them, but we can use my flow chart. In step 2, it says, are the signs the same? Yes or no? These signs are the same. They're both positive. Okay, so the next question on that part of the flow chart says, is it the same number? Are these the same exact number? No. So how do we answer this one? Is it parallel? Is it perpendicular? So what do you say? Neither. Now, the way you answer this question is very wordy if we actually said it correctly. We should have written down here, the lines are neither because they are not equal and not opposite reciprocals, but that's a mouthful, so we're just going to say nothing because the slopes are not related to each other in any specific way. They are not the same. They are not opposite reciprocals. They're just two random numbers, unrelated. Cool, cool, cool. Now, if we put this all together, this is the big kind of question you're going to see today. I'm going to give you lots of information at one time and ask you to do many different parts. For number 9, it says determine which lines, if any, are parallel and or perpendicular. How many lines are on this paper? 4. Guess how many times we're going to need to find slope? 4 times. But look at all of this stuff. We have all of these different coordinate points to label and not get confused. So this is kind of like when we did distance formula, one where if you don't use color-coded markers, you're going to want to erase your labeling every time. I'm going to use my color-coded pen, so it's going to stay up there the whole time. I don't recommend that for you unless you specifically have a marker like that. Let's go in alphabetical order, which means I'm going to do the blue line first. So I'm going to find the slope of A. So I'm going to call it MA because it's the slope for line A. For the slope of line A, I need to label some points. I'm going to label this x1, y1, and this one x2, y2. It's kind of hard to tell because I'm writing in blue along with me. I'm labeling this point, -3, 2, x1, y1, and this blue point, which I know is not colored on your paper, 0, 3 is x2, y2. So when we do our slope, this would be 3 minus 2 over 0 minus -3. Bleep, bleep, blop. Calculator question. That's going to be 1/3. Fabulous. I found the slope of the blue line. Next letter in alphabetical order is B. For me, B is that red one. So I'm going to find the slope of B. Again, we're going to label our points. This is, again, where it's going to get confusing. Erase your first labels if it's going to confuse you. This is x1, y1, and x2, y2. We throw that into the formula. y2 is 0, y1 is -1, x2 is 2, x1 is 0. Bleep, bleep, blop. Calculator question. Are we okay with me fast forwarding through the calculator part? Yes, thank you. Okay. We would get 1/2. Let's make sure you know where these numbers are coming from. I want you to find the slope of C, which for me is the green one, and the slope of D, which for me is that purple one. You're finding those slopes, so label the points, find the slope. Before you ask me a question, there must be labels on your points today. Then I will help you. For line C, the green one, I labeled my points, I threw it in the equation, and that equation tells me that it's 1/2. Did we get that? Now the purple one is a little confusing, and Kate had a good question. The purple one, because mine has the colors like on it, there's not 2 purple coordinates. However, if I look here, this dot is also on the blue line. And it's going to really confuse me if I have 2 sets of labeling. So I'm actually going to erase my labeling from the blue so that my labeling from the purple doesn't mess it up. So this is going to be x1, y1, and then x2, y2. Again, if you labeled yours differently, don't panic. It may end up being the same thing after we finish. When you do this, 2 minus 0 over -3 minus -2, you should get the number -2. Now we've gotten all of these slopes. Again, finding the slope is the same as it's been all class, but comparing them and telling me the answer is a little bit different. If I ask you first, which lines are parallel? Which lines are parallel?
B and C.
Why are B and C parallel? You are correct. They got the same slope. So the way we're going to answer this is with symbols. We're going to say line A, just kidding, that's line B, is parallel to line C. Okay, so line B, parallel, that's the symbol for parallel, line C. Cool? Now, which ones are perpendicular? Which slopes are opposite reciprocals?
D, B, and C.
D and B and C. So the way we would say this one is we would say line B and line C are perpendicular to line, spelled that wrong, it's embarrassing, line D. So there are two different lines that are specifically perpendicular to D because we're comparing these slopes together. Line A is not related at all to any of them. That's not a flipped fraction, nor is it the same sign. So we know line A is gone. No thank you. But these two are the same, and they're specifically the opposite of this one. So line B and C is perpendicular to line D, and line B and C are parallel. So you're going to see a mixture today of the words written out parallel, perpendicular. I'm no longer going to write those words because that's too many letters, and I'm probably going to spell it wrong. I'm going to use the symbols for it so that you get used to seeing the symbols. We're going to practice today with a gallery walk out in the hallway. We've done these before. It's one of those where you can start in any card and it leads you in a loop. Y'all know what I'm talking about? Where the answer is on a different card. Yes? No? Okay, fabulous. Before you ask me any questions today, if it's specifically asking you to find slope, which most of them are, I need you to have the points written on your paper and labeled. Then I will help you. But if you are not doing step 1, I'm going to wait till you've done step 1 to come help you. You must label your points before you ask me a question. Understood? Now you can work with a partner on this activity, so go ahead and find a partner. Grab a clipboard. You have your paper in your hand already. We'll make sure we get this finished. When you finish, you can come back inside and work on your homework assignment, which is that MHS paper right there. All right, that's what we're doing for the rest of class. Here we go.